Hey guys, it's RJ. I'm going over to summation notation. Summation notation is used to define the definite integral of a continuous function of a variable on a closed interval. Now, if fi represents an expression or function involving I, then this sigma, as it's called, has the following meaning: fi, equals f1 plus f2 plus f3. The I equals part underneath the summation sign tells you which number to first plug into the given expression. The number on top, represented by n of this summation sign, tells you the last number to plug into the given expression. You always increase by 1 at each successive step. Now, on to the next one. The next one is the sum of an arithmetic progression, also called an arithmetic series. It looks something like this. This is the arithmetic series. This sum can be found quickly using the equation n times a1 plus an divided by 2, and we're simply taking the number n of terms being added, 5 here, and multiplying by the sum of the first and last number in the progression, 2 and 14, and it's going to equal 16 right here, as you can see, and dividing by 2, and in the end you get 40 for sure. Next one. We're now going over the sum of a geometric progression, also called the geometric series. It looks something like this. The sum can be found using the equation a times 1 minus r exponent m divided by 1 minus r, a being the first term 2, m being the number of terms 4, and r being the constant that each term is multiplied by to get to the next term. 2 times 5 is 10, and 10 times 5 is 50. The example answer is 312. As you can see right here, just keep going and you get the equation and then you get the answer. And yeah, that's it. Now on to the pyramid of Sleeza.
Geometric sequence versus arithmetic versus neither. So basically, so geometric sequence, skills. Look at Katie's fine skills really quick.
You already know.
Okay. So, geometric sequence is like when there's commas. So, sequence, first of all, is when there's commas. No, like, pluses in between.
No, plus 2.
Addition. Katie, shut up. Okay. And then, so also geometric is when you're multiplying between numbers. Like 4 times 2 is 8, and then you're doubling each time. But then, arithmetic is when there's commas. There's for the sequence, like a regular sequence is. Except you're adding in between the numbers. You're adding in between the numbers. Plus 4 plus 4, like for example, plus 4 plus 4. And then neither is when there's no common ratio. So like if there's no, like, see, like these are different every time. Like here you're adding 3, and then you're adding like 10, then you're adding like 100, then you're adding like 1,000. So it doesn't work. So then when there's no common ratio, it's neither, right, Kate?
Right.
Okay, we got the pyramid of Sleeza. So what we're doing is we're going for the rounds, right, of a pyramid of Sleeza. We're doing a not a Ponzi scheme. That'd be bad. We're doing a pyramid scheme, right? What we're gonna do is trying to find out how many people we can get into a 17 rounds of a pyramid scheme. Right here, as you can see, we got a consecutive 1, 2, 3, 4, 5, 6 rounds, and we got about 1,092 people. We just want to do a equation to find out our 17th round of this pyramid scheme, and with 300 million people. So what we're gonna do is we're gonna find out that how we have the 3 here. We got the geometric right here. This whole thing is geometric. And the new participant makes it a series, so we got our geometric series. We're gonna use the geometric series plus the 300 million to get the equation we have here. So we're gonna factor that out. We got this. We're gonna cross out the 3's here. Then we are going to, simplify, get the 200 million, and then we're going to go up here. And then we got a nicely written 200 million equals 3n. Then we're just going to use log in a calculator, just put that into your calculator. And then down you would get 17.4. Well, the 300 million, right? You see the 300 million, the connection of this equation to the 17 rounds, if you round it right here. Then yeah, you got 17 rounds, and that's 300 million people. So that is your pyramid scheme, and that totally works. Onto either Kennedy or Katie's, and that sums it up about for the pyramid of Sleeza. Alright.
Stocking apples. Kate.
What?
¿Te gusta manzanas?
Sí. Muy.
¿Te gusta mucho manzanas? Stocking apples. Okay. So, say like you have 15 layers of apples just stacked on top of each other, like 1, 2, 3, like 15 layers of these.
Right now, I hope you realize.
Yeah.
Okay.
And then there's two ways you could solve this. You could do summation notation, which is like the simpler but longer way. Oh no, it's not simpler, it's just longer. And so like since there's 15 layers, you put on the top of this sigma. And then since there's it's like squared every time, I squared, and then I equals 1, you start with 1. So you could do the long way and square each number. 1 squared plus 2 squared plus 3 squared plus 4 squared all the way to 15, and you'll get 1240 apples. And if you do sum of squares, you'll get the same number but in a different way. You'll do n times n plus 1 times 2n plus 1 over 6 divided by 6. So then your n would be your layers, so 15, and then you just fill that in, and then you solve and you get the same answer. So there's two ways to solve and all together stacked, like all these to stacked. And if you want to find a specific row, you just square the numbers. Like if you want to find the third row, you just square third row, like 3 times squared. And then you get that row. So yeah, it's pretty simple. Right, Kate? Muy fácil.
Muy fácil.
Retirement investment with Katie Buckley.
Okay. Hook me up. Alright, so, thanks. Oh god. So you deposit $6,000 in a bank account that pays a 7% annual interest rate, and this deposit every year for the next 32 years. You make this deposit every year for the next 32 years. So how much money is in it after the last deposit? So you start by doing year 1 plus year 2 plus year 3, and that's 6,000 plus 2420 plus 9 plus 192898.40 ... 32. So then each time you're multiplying by 1.07 and adding 6,000 each time, which means that it's a geometric series because you're multiplying. Okay, and then so for the common ratio, which is r, you have to do the equation Sn equals a1 parentheses 1 minus rn to the power, and then over 1 minus r, and that gives you r, which is 1.07. And then that's the second step. And the third step is putting 6,000 in for a1 because it's the first number in the thing, and then you do 1 minus 1.07 over 1 minus 1.07 again because that's the equation, and you raise it to 32nd power, and then you get 661,308.93. $661,308.93.
She's smarticles.